This is a calculus video, and in this video we're going to calculate the average value of a function over a closed interval. In order to do that, we need to look at the formula for the average value of a function, and before we actually use this formula, I'm going to explain to you kind of where it comes from, what it means, and give you some visual orientation so you have an understanding for this. So if we think about a function on a closed interval, and let's make that function positive on that interval. So let's go from a to b. And remember, the value of the integral from a to b is the area between the curve and the x-axis, and in this case that area would be positive. So if this is f of x, our area would be f of x dx from a to b, and that would represent the area. Alright, now what we actually want to do is find the average value of the function on this curve. So if we think about what the value of the function is at the curve, if I look at this c value, I have a function value here. Here my function's value, it increases. So my function doesn't have the same value as we move from a to b. So to figure out what the average value would be, we need to somehow think about this space in terms of geometry. So if I could take this area and kind of level this y value out so that it was constant across the curve, and I've got to kind of figure out where this goes so that this area exactly fills this area in. So I might want to move that curve or that line down a little bit lower. What we're looking for is a rectangle that has exactly the same area. And if we figure out the height of this rectangle right here, this would be our average value of the function. And I'm going to call that the average value of f. So let's think about what we're doing in terms of the rectangle. If we take our rectangle, we have a width and we have a height, and our width times our height equals the area. So let's think about this in terms of our interval here. The width of our interval is b minus a if we look at our graph. The height is our function, and this is going to be the average value because if we look at the height of the rectangle, that's always going to be constant. So we're going to turn the height into the average value of our function, and that's going to be equal to the area of the curve, which we said was the integral from a to b of our function dx. Now if we solve for this average value, what we end up with is the average value of f, so AVF equals, and we're going to divide both sides by b minus a, so 1 over b minus a times the integral from a to b of f of x dx. And this is where our formula comes from, which is what we have here. So essentially this is what we're trying to accomplish. We're trying to figure out if we could squish our irregular area into a rectangle with exactly the same area, how tall would that rectangle be? What would the height be? That would be the average value of the function. So if we could take this value that's constantly changing and average it out to a constant, what would that constant value be? Alright, so hopefully we have a better conceptual understanding for what we're doing now. Now let's apply this knowledge to an example. So here's the example we're going to do. We're going to find the average value of the function over the given interval, and let's just repeat our formula here. Okay, so the first thing we're going to do is we're going to start plugging things in. The average value of our function is going to be 1 over our b minus a, which is 3 minus 0, from 0 to 3, for our function 4 minus x squared dx. At this point, it's just a matter of taking the antiderivative and evaluating what you've got. So the average value of the function is going to be 1/3 times 4x minus x cubed over 3 evaluated from 0 to 3. Now this is just a matter of doing the arithmetic and getting the right answer, so be careful when you do this. Make sure you write this step out. It's easy to make silly errors, so you want to make sure that you're writing enough out so that if you make an error you can easily find it, go back and fix it. So your final result should be 1/3 of 3, which is 1. So what this means is the average value of your function equals 1. All right, which means that if we took the area trapped between the curve and the x-axis and averaged it out, we would get a value of 1. I hope this video made sense. Make sure you practice. Make sure you ask questions if you need help.